61. Let's calculate. OH ion concentration in the aqueous solution of 0.1 molar H2SO4 at 25 degrees Celsius is. Let's calculate this question, students. We all know that the concentration of H plus ion and OH minus ion is equals to 10 raised to the power minus 14 at 25 degrees Celsius. Now students, we are given with 0.1 molar H2SO4. We all know that H2SO4 gives 2 H ions. So H plus concentration will be 0.1 into 2, that is 0.2 molar. So OH ion concentration, that is concentration of OH ion, is equals to 10 raised to the power minus 14 upon zero point 0.2, which is equals to 5 into 10 raised to the power minus 14, or which is 0.5 into 10 raised to the power minus 13 molar. That means the correct answer is option number 3. Moving to next question, which is 62. What is the pH of a 10 raised to the power minus 6 molar aqueous solution of NaOH at 25 degrees Celsius? Student, here we are given with 10 raised to the power minus 6 NaOH at 25 degrees Celsius. We have to calculate pH. So student, pH plus pOH is equals to 14 at 25 degrees Celsius. And we are also given the concentration of OH ion in solution, which is equals to 10 raised to the power minus 6 molar. That means we can calculate pOH, which is equals to minus log 10 raised to the power minus 6, that is 6. So we can calculate pH, which is equals to 14 minus pOH, which is 6. That means pH is 8. So the correct answer is option number 3. Moving to next question, which is 63. Let's read it. For the reaction, N2 gaseous plus 3H2 gaseous gives 2NH3 gaseous and heat. The reaction will proceed in the forward direction on. Option number 1, increasing both temperature and pressure. Option number 2, increasing temperature and decreasing pressure. Option number 3, decreasing both temperature and pressure. And option number 4, decreasing temperature and increasing pressure. Student, for such question, we need to know that increase in pressure shifts the equilibrium towards lesser number of gaseous moles. That means for this reaction, increase in pressure will shift the equilibrium towards the product side. That means the reaction will proceed in the forward direction on increasing pressure. Now let's talk about temperature. This is an exothermic reaction because heat is released in the product. So we need to know, again according to Le-Chatelier principle, for exothermic reaction, equilibrium will shift in the forward direction on decreasing temperature. That means the correct answer is option number 4. Moving to next question, which is 64. Let's read it. If 2 moles of calcium carbonate is dissociated in a closed container of volume 10 liter as CaCO3 solid, CaO solid plus CO2 gaseous, Kp is equals to 2 atm at 800 degrees Celsius, then degree of dissociation of calcium carbonate is. Student, for this question we can see that Kp is equals to partial pressure of CO2 gas, which is equals to, because we are given with the value of Kp. So student, we all know that PV is equals to nRT. That means pressure of CO2 is equals to nRT upon V. So we can calculate number of moles, which is equals to pressure of CO2 multiplied by volume upon RT. So let's put the values. Pressure of CO2 is 2 and the volume of the container is 10 upon R. R is equals to 0.0821 multiplied by temperature, which is equals to 800 degrees Celsius. So let's convert this into Kelvin. It will be 1073, which is equals to 0.227. Students, now we have calculated the number of moles of CO2 produced at equilibrium. So we can calculate the degree of dissociation. So alpha degree of dissociation is equals to number of moles of CO2 produced, that is 0.227 upon total number of moles of the reactant present, which is equals to 2. It's already given. that 2 moles of calcium carbonate are present. That means alpha is equals to 0.113. So the correct answer is option number 3. Moving to next question, which is 65. Let's solve this question. If 100 ml solution of pH is equals to 2 is mixed with 100 ml of solution of pH equals to 3, then pH of the mixture will be. Student, here the first solution we are given with has pH 2. So pH of the first solution is 2, and that means the concentration of H ion here is 10 raised to the power minus 2. Here I'm writing 1. The volume given, let's take it as V1 is equals to 100 ml. Now let's talk about the second solution. The pH of the second solution given here is 3. That means the H ion concentration for the second solution is 10 raised to the power minus 3. And the volume given for the second solution, let's take it as V2, is also 100 ml. We have to calculate the pH of the final solution or the resultant solution. The formula used is M1 V1 plus M2 V2 is equals to M resultant into volume resultant. Here M1 is 10 raised to the power minus 2, volume is 100, plus M2 is 10 raised to the power minus 3, volume is again 100. Let's take the total volume or the volume resultant into the denominator, which is equals to 200, which is equals to molarity of the resultant solution. Let's calculate this. This will be equals to 5.5 into 10 raised to the power minus 3. This is the resultant molarity or the H ion concentration in the resultant solution. Student, you have to multiply and divide the entire thing here. I have already calculated. So let's calculate pH. So pH is equals to minus log concentration of H ion. So minus log concentration, I'm putting the value 5.5 into 10 raised to the power minus 3, which is equals to 2.26. That means the correct answer is option number 2. Moving to next question.